of two proportions. Scientists predict that global warming may have big effects on the polar regions within the next 100 years. Of the possible effects, that is the northern ice cap. One of the possible effects is that the northern ice cap may completely melt. Would this bother you a great deal, some, a little, or not at all if it actually happened? The GSS asked the same question to the general population, a group of randomly selected Americans, as well as a group of introductory statistics students at Duke University. So, our parameter is the difference between the proportions of all Duke students and all Americans who would be bothered a great deal by the northern ice cap completely melting. We want to determine if Duke students are significantly different in their opinions compared to the general American population. So, we're going to do this by doing a difference of proportions. Our point estimate is the difference between the proportions of the sampled Duke students and sampled Americans who would be bothered a great deal by the northern ice cap completely melting. To indicate the sample, that's the hat on the P. Conditions for a difference of proportions. Independence within groups. The U.S. group is sampled randomly. We're assuming the Duke group represents a random sample as well. 10% condition. That the sample of Duke students is less than 10% of all Duke students, and the sample of Americans is less than 10% of all Americans. So what was our sample size here? Right? So there are more than 1,050 Duke students, and there are more than 6,800 Americans. So verify those. So 10% condition. We are assuming that the attitudes of Duke students are independent of each other and attitudes of U.S. residents in the sample are independent of each other. These are some big assumptions, but we have to make these assumptions in order to be able to do the math. So we just note that we're making these assumptions. We also need independence between groups. So the sample Duke students and the U.S. residents need to be independent of each other. That seems safe to assume. And so this is our large counts condition. At least 10 observed successes and observed failures in the two groups. So we don't have a single proportion that we can do NP and N1 minus P. So at least 10 observed successes and observed failures. The mean of the sampling distribution is going to be the difference of the two proportions. Standard deviation of the sampling distribution, right? So remember that our standard deviation for one proportion is the square root of P1 minus P over N. Here, you just do that for both populations, add them together before you stick them under the square root. All right? Again, we add the variances, and then we square root it. Because if we take away the square root, if I take this square root away, this is the variance. So, variance of the two, add them together, and then square root it. And that gets you your standard deviation, just like we've been doing this whole time. The mean of our difference between two proportions is going to be the difference between the two proportions. So the sample for all Americans, the proportion was 454 out of 680, which is 0.668. And for Duke students was 69 out of 105, which was 0.657. So the difference in the proportion between Duke students and all Americans who would be bothered a great deal by completely melting polar ice caps. I think we did Duke minus all Americans, which would be 0.657 minus 0.688, which is negative 0.011. The standard deviation of the sampling distribution, gonna be a little bit trickier, but we'll plug this in here, right? And so that's going to be the square root of 0.668 times 0.332 over 680 plus 0.657 times 0.343 over 105, and that ends up to be about 0.05. If the proportions are equal, meaning that the mean of the sampling distribution is equal to 0, what is the probability that we would get a difference in proportions at least as big as this? So we already checked our conditions, right? We have at least 10 successes and at least 10 failures. We're assuming independence. So we can use the normal distribution, the normal approximation here. And we want a difference that's at least as big as 0.011, which is going to be this part of the distribution. So you could use your normal CDF with a lower bound of negative 1E99, an upper bound of negative 0.011, mean of 0, and a standard deviation of 0.05. But it says a difference in proportions at least as big as this, and doesn't specify the direction. It doesn't say what's the probability that the proportion for all U.S. Residents is at least this much. It just says a difference in proportions, which could go either way. So what we should do is we should also find this part of the distribution. A difference of at least this big, with Duke being bigger. Now, because the normal distribution is symmetric, this distribution is going to be this tail is going to be the same as the other tail, so we can just take our normal CDF that we already found and multiply it by 2. And this, when you plug this into your calculator, ends up being 0.413. So when you multiply that by 2, that ends up being 0.826, which is very large as a percentage, right? So if there is no difference between Duke students and all Americans on this issue, there is a almost 83% chance that we could see a difference at least this big. So are we convinced that there really is a difference in the opinions of Duke students and Americans? Probably not. There's a very large probability of getting a result like this if there's no difference at all. So we cannot say that there is a difference. And that's it. That's the difference of two proportions. Calculating the standard deviation is a pain, but that's why you have formula sheets. Other than that, it's basically just like doing it for a single proportion.